Hi, my name is Mark Yatskar, and I'm going to be giving the fourth case study in this crowdsourcing tutorial about question answering in context QUAC. So what is QUAC? QUAC is essentially an extension of question answering kind of in the flavor of squad to multiple turns. So in kind of the original question answering formulation, there'd be a questioner who could ask a question like, when are hops added to a brewing process? And we would expect a model given a Wikipedia page that contains sufficient information to answer this question. The model would scan the page and find an appropriate span for answering this question, like the boiling process. And so QUAC's extension of this interaction is essentially to let the questioner ask follow-up questions that build on the knowledge that they've obtained in kind of previous turns. So the questioner could ask something like, why is the boiling process necessary? And the model would need to use the context of this exchange to integrate information and kind of appropriately answer this question. So at the very least, it would need to resolve the co-reference and then go to the Wikipedia page and find an appropriate span to answer this question. So the specific formulation for QUAC involves two parties. So one is a student whose job is to learn about a topic, and another is a teacher whose job is to teach about the topic. And each of these roles has some amount of information which is specific to them to help them fulfill their role. So the student will be given an entity name and the first paragraph of a Wikipedia page corresponding to this entity. And this entity will be the subject of the conversation, but we won't allow the student to ask anything at all about this entity. We'll kind of ask the student to constrain the conversation to a particular topic around this entity. And the teacher will be given all the information that the student is given, in addition to supporting material for answering questions about that topic. So the actual section from the Wikipedia page that the student needs to discuss. The final job of the student is to learn as much as possible about this topic. And the teacher needs to supply answers which are extractive spans from the target Wikipedia section, or kind of indicator that a question that the student is asking is unanswerable. So what's an example? This is a dialogue we really collected for the data set. So the subject of this dialogue is the origin of Daffy Duck, the cartoon character. And so the student starts out by asking, what is the origin of Daffy Duck? The teacher can find an appropriate span and say, if they first appeared in Porky's Duck Hunt. The student can follow up just based on their interest and ask, what was that episode like? And the teacher might be able to find some amount of information. The dialogue can continue, and the student ultimately wants to know if Daffy Duck was the central figure of that episode, which he was not, and kind of naturally follows up with, well, who was the central figure of this episode? But this information is missing from the supporting material of the teacher. And so the teacher can simply say, cannot answer, the question is unanswerable. And so we've collected 14,000 dialogues of this form. The dialogues are roughly 7 QA pairs long. And in total, there's around 100,000 question answer kind of interactions. So this is on the scale of squad. So what is this case study going to focus on? So I'm going to mostly talk about the progression of QUAC from kind of its infancy when we were first starting to formulate this collection process and how we got to the kind of final formulation the way we did. I want to mostly focus on things that didn't work and how we tried to identify that, and then what we did to manage some of the failure cases that we were seeing. So what was our crowdsourcing process? Overall, we collected QUAC in about 5 months on Amazon Mechanical Turk. What's kind of unique about QUAC is the vast majority of our collection process and development process didn't take place on Amazon Mechanical Turk at all. So we spent the majority of our collection process simulating interactions between teachers and students, among ourselves, the authors, and among recruited NLP researchers in pilots. And this was actually the vast majority of the effort for developing QUAC went in this kind of in-person simulation of crowdsourcing. And then finally, once we were confident enough, we very quickly moved to Mechanical Turk and collected essentially the entire data set. So what were our initial goals when we started this process? We started fairly ambitiously, and the kind of pilots were used to pare down our kind of real goals. So how did this start out? Essentially, we wanted to formulate conversations which were unconstrained between teacher and student, so they could say anything to each other. And these conversations would be driven entirely by the student's curiosity. So there wouldn't necessarily be any kind of guidance in terms of what the student followed up on and what they didn't. And we wanted to have these conversations on essentially any topic in Wikipedia that we could find supporting resources for. After the conversation, we wanted to be able to demonstrate that the student had learned kind of important information about the topic, and that in some sense, this was the ultimate measure of success of the dialogue. Okay, so we had several concerns going in. So kind of on this very high level perspective of goals, we didn't know if we could define a task that wasn't extremely burdensome for the student and the teacher. In particular, we were concerned if it takes, an hour to have a dialogue between these two parties, we could never scale the collection to Amazon Mechanical Turk in any kind of reasonable way. The other concern was thinking about whether or not we could produce realistic data such that the data was challenging and interesting. And this really grounds out to, well, we wanted interactions that were long enough. So within a particular topic, we wanted the student and the teacher to have enough exchanges that kind of natural behavior between them developed. And the final kind of big concern we had was how do we avoid bias during the data set collection process? So how do we avoid having any artifacts in the data such that ultimately the data will be not that useful for the community because it's easily solved because of some sort of simple trick that a model could exploit. And so we didn't have a lot of ideas about all of these concerns. So the first two we developed intuitively over the course of our pilots. The last one we actually had fairly strong opinions about early on, and kind of worked as constraints for our data collection process. And so we were influenced by this paper from Robin Jai and Percy Liang, analyzing essentially potential biases in Squad and showing that models that are trained on Squad are fairly sensitive to kind of lexical overlap between questions and answer sentences. And our kind of hypothesis here was that that's happening because students in the Squad setup were able to see the supporting material that they were asking questions about. And in reading that supporting material, that biased the form of their questions such that it had significant lexical overlap with the actual answer to their question. And so a constraint for our collection was that the student should be as maximally uninformed of the supporting content that they're going to be talking about as possible during the collection process. So the student can't see the paragraph that they're asking questions about, and the teacher needs to avoid telling the student any kind of unrelated content to the question that they're asking, so that the teacher doesn't implicitly reveal too much content, which would then ultimately bias future questions that the student has. So those were our constraints. And so here was kind of the first initial baby version of QUAC. It has some of the kind of characteristics of the final version, but it's significantly more involved. So the setup is we're given, the student and the teacher are given an article, a name, and the teacher is given an entire article to read and then design a quiz about. And this quiz is going to be designed to ultimately be administered to the student to verify that the student has understood and asked questions about all of the kind of relevant, interesting material in the article. The student needs to ask questions entirely from just the article name until they feel like they've learned enough, and then is subjected to the final quiz that the teacher designed and evaluated based on the quiz to see if they've succeeded at learning about this Wikipedia article. Okay, so the way we explored this idea was actually fairly ad hoc. And so initially we didn't know whether this would work or not. And so we wanted to invest minimally in terms of coding and any kind of turking to see if this kind of setup was possible. And so what we did is what I'm calling office conversations. At this point, in 2018, Mohit and I were sharing an office at AI2. So I would open a text file and then Slack Mohit and declare, hey, you know, I have a topic that we should talk about in the context of this QUAC project that we're thinking about. At the time, I was really into spiders. So I would try to get Mohit to talk about spiders. And I'd tell him I have a quiz, he'd agree, and we would proceed to have a conversation. And this conversation, we would just record in the text file as we were going for kind of future reference. Okay, so the conversation would roughly proceed as you can imagine. Mohit was reasonably cooperative in my obsession with spiders and did in fact have these conversations with me. Eventually he got tired and declared he would like a quiz. I obliged, and we found that Mohit had failed to learn anything that I found interesting or important about spiders, and he was extremely frustrated. And of course, this wasn't the end of it. So we kind of, I persisted. I thought, you know, questions or conversations about spiders were really a great idea. And so we would go off and find other people to try to simulate these kinds of conversations just in a text pad and a Slack window. Ultimately, we kind of spent a month doing this, kind of just simulating, and had probably 50 conversations. And I would say most of these conversations were fairly unsuccessful. This really caused us to rethink many of the goals that we had formulated originally. First, we needed to change the kind of possible topics that would be kind of conversed about. So Mohit did not share my passion for spiders at the time. And so we needed to have some sort of common ground for conversations that could be reasonably engaging. And so we agreed that we would not have, we would not allow any Wikipedia page as a topic of conversation, that these had to be simple kind of pop culture topics that needed to be discussed. And finally, we completely gave up on this idea that the student actually needed to demonstrate in any way that they had had a successful conversation, because it was very difficult for the teacher to predict the kind of interests of the students. I think the important point here is that really what we did for a month is kind of simulate enough conversations that we became intimately part of, or intimate with how exactly this data collection could happen. And so we were able to kind of, with very, very little data, make fairly broad changes to our goals and the kind of potential setup of the task. Okay, so this was the new version after 50 dialogues. Essentially, what we've done is move closer to the final form of QUAC, where we did completely remove this quiz. We're still talking in terms of entire Wikipedia articles, and the teacher was able to respond to the student in any kind of free form interaction, and the student was able to ask any question in free form. So we're feeling pretty confident at this point. So what we did is recruit people that weren't us to participate in these conversations under this new QUAC version 1 formalism. The way this worked is essentially we would ask a few people to join us in an office. They would be the workers to simulate the conversation, and the QUAC team would be there to watch and try to understand how the annotators are behaving during the annotation process. And in particular, we were very concerned with how are they spending their time, because this would ultimately affect the final Turking experiment on Amazon Mechanical Turk. And then afterward, we had fairly extensive postmortems with these simulated workers, where essentially we just had conversations asking them what they thought about the task, what did they like, what did they think worked, what didn't work, in kind of a fairly natural way. So qualitatively, what kinds of dialogues were we getting at this point? This is I think we didn't actually maintain logs of these conversations. So this is my kind of remembrance of exactly how they went. The kind of scenario was 2 people would sit down, we'd point the teacher to a Wikipedia page, and then we would wait. We would essentially wait for 5 minutes while the teacher would sit there and try to consume the content of the Wikipedia page. Everybody would chit chat, the teacher would silently read. After the teacher kind of declared that they had kind of finished reading, the student would ask a question, something like, when was Daffy Duck created? Given that the topic is Daffy Duck, the teacher could answer something short, like 1937. At this point, we would be waiting for the student who would be trying to think of a reasonable question, because they had fairly little information about the article of Daffy Duck at this point, and they were trying to ask something reasonable. Eventually, the student would settle on a question like, did his appearance ever change? And the teacher would have to scan an entire Wikipedia page trying to find the answer to this question, declare that they can't answer the question. A student, somewhat discouraged, would again think for a fair amount of time trying to come up with a good question to ask the teacher, come up with something, and then again find that the teacher, after a fair amount of time, couldn't answer their question. So, okay, I would call this an overall unsuccessful interaction. as from my memory, the kind of feedback that we got was that there was way too much waiting for a partner, and that individual exchanges were fairly hard to execute. So each of the two parties had their own flavor of complaints. So the student kind of said, okay, hey, it's unreasonably hard to ask good questions. And the teacher was sympathetic to this kind of complaint and understood and said, hey, they would like to help the student in some way, ask reasonable questions, but there's no useful mechanism to do so. And finally, the teacher would complain that, hey, mostly they're just restating information in the article and loosely copying Wikipedia content. Why can't they just directly copy or extract spans from the Wikipedia page? Because they were mostly doing that anyway. Okay, so to deal with some of these concerns, essentially we had to move away from having fully unconstrained conversations. And the key was to really narrow the focus of both the student and the teacher. So the student's complaint was it's really, really hard to ask good questions. It was kind of played out by the fact that most of the students' questions were unanswerable. And so what we chose to do is actually try to give the student more background information about the topics that they'll be talking about. If the kind of overall topic was Daffy Duck, we would give background information in the form of the first paragraph of Daffy Duck's Wikipedia page. And then we narrowed the actual topic of discussion to a single section of the Wikipedia page, so just the history of Daffy Duck. This could solve two things, right? So the student could use their kind of common sense knowledge to know roughly what kinds of things to expect in a historical account of a cartoon character. So maybe if they were canceled or something like that. But also the teacher would need to search less text to try to provide responses. So the responses could come faster. The teacher kind of complains that they were restating information in the article. And so essentially we constrained the teacher to only select spans from the article as kind of a compromise where they're still doing most of the behavior that they want, but A will be faster and B will be easier for them. Okay. The last kind of large change that we needed to make kind of based on the feedback from these pilot studies was that the teacher was unable to communicate useful information to guide the student. And originally in our formulation, we wanted the entire dialogue to be driven by the curiosity of the student, but this became a hindrance to ask useful questions. And so the concern here was, hey, if the teacher was guiding the student too much, this would be a source of bias in the collection process. So for example, if the teacher just told the student the type of information that's in the article or in the section, then the student's questions would look like the content in the section. So our solution was essentially to allow the teacher to communicate this type of information with the student, but not having any lexical kind of information transmitted between them. So essentially, the teacher would be given a button with every question answer turn, where once they gave an answer to a question, they told the student whether or not the student should continue in this line of questioning for sure, maybe, or not at all. And the kind of information was always transmitted to the student in this categorical way using the same terms no matter what. So, okay, so just to summarize the kind of trend here, essentially we started with this fairly ambitious goal of having unconstrained conversations between student and teacher, entirely driven by student, with this kind of proof that the student had done a good job at learning the content that they wanted. And essentially, we ran roughly 100 kind of pilot flavored experiments where we personally did most of the conversations and essentially had to pare down a lot of our goals to be something that appeared accomplishable on Mechanical Turk. So the final kind of version of the high level picture here was we were going to have an extractive conversation between student and teacher. The conversation would be guided by the teacher, and the topics would be fairly simple, such that the conversations were easy to execute. Okay, and this was essentially the final version of QUAC, where the student is given the kind of first paragraph of about an entity from Wikipedia and a name of a section that they need to discuss. The teacher is given that section and this Wikipedia content. They both read their initial materials, and then they have a conversation where the student initiates and the teacher gives responses in the form of spans or says that they can't answer, and encourages the student in the form of follow-up, maybe follow-up or don't follow up categorical cues. So this was actually a fair bit of the work having to do with crowdsourcing QUAC. This was over the course of 4 months. We iterated all of these kinds of ideas, doing the dialogues ourselves. And at this point, we were ready to actually go to the crowdsourcing platform. And so QUAC inherited a crowdsourcing interface from one of Hehe's papers in 2017, where essentially they set up a dialogue between two workers. And the kind of architecture of this interface was essentially that Mechanical Turk was used to recruit people, and then they were taken to a external application that was hosted on some other web server, where this application would actually coordinate all the machinery of having a dialogue. So the crowd workers were taken to this application. They would wait for a partner. They would be randomly assigned a teacher or student role. They would execute a QUAC dialogue and then receive some sort of hash code. They would take this hash code, go back to Amazon Mechanical Turk, and then put the hash code into a form, and then that's how they got paid. So here are the results. Essentially, this initial pilot was fairly unsuccessful. And the main problem was the amount of time that the collection took. So because of the asymmetry between teachers and students, students were waiting for teachers when teachers were finding answers, and then teachers were waiting for students when students were finding answers or thinking of questions. And so most of the conversations were abandoned out of sheer boredom after just a few exchanges. And so how did we know people were bored? Essentially, we went to forums where people were discussing hits on Amazon Mechanical Turk. And there were huge complaints about how essentially people are just sitting around waiting for their partner to do anything. And so we needed to solve this problem. And essentially, there were two tricks that we came up with to get around this. The first was to give workers more to do. And the second was to think carefully about incentives. Okay, so what did it mean to give workers more to do? Essentially, we decided that we could try to make pairs of workers conduct two dialogues simultaneously, where in one dialogue they're playing the teacher role, and another they're playing the student role. And the dialogues would be related. So they would be about the same article, so about the same entity, but the subjects would be different paragraphs. And the students and the workers could alternate the roles. So And kind of the first worker could ask a question, the second worker could ask a question on different topics, and then both workers could look for answers to questions that the opposite worker had posed to them at the same time. The kind of huge advantage here was that the work was predictable. So the workers would show up, they'd know exactly what they were doing all the time. They wouldn't sometimes be teachers, sometimes be students. They would always be both and always be actively engaged during the whole process. The second aspect that we needed to think carefully about was compensation. And essentially, we needed to try to encourage workers to have longer conversations and stick it out, even if there were problems within the conversation. And so the way we did this is essentially we paid people per question per answer that they gave in a exchange, but the later turns within the exchange would be worth more. So essentially, we set up this polynomial kind of growth pay scheme where every question would be worth some amount of money, and every subsequent question would be raised to some sort of power. So we came up with kind of reasonable factor, 1.2, such that the first question would be worth 10 cents, the last question would be worth roughly 18 cents. And so you might think like, oh, was this like extremely hard to explain to Turkers? Well, it was kind of surprising. We're very worried about this. The kind of diagram on the right here is exactly what we showed workers to help them understand how this pay scheme worked. So A, we wrote the equation, but B, we made this kind of giant table that showed if your partner was on some sort of state in the dialogue and you were in some other state, you could look up your current reward for the job that you were doing. The second aspect that we implemented was punitive. Essentially, we said, hey, if your partner did some work and you didn't respond, you should be paid less. And so this was maybe a somewhat controversial kind of a scenario where essentially we said, if you left one of your partner's questions unanswered, then your reward would be roughly 10 cents less. So we've highlighted kind of in this state diagram, all the red states are punitive states for the kind of current worker. And the kind of idea here was essentially to discourage wasted effort. And so if a partner had bothered to formulate a question, we couldn't use it in our final data set unless there was a corresponding answer. And so we penalized a worker who behaved in this way during the collection. So how big of a pilot did we do? Not too big. We kind of sampled, we managed to put together 100 dialogues, so less than $1,000 total on Mechanical Turk. The kind of intuition here was the pilot should be big enough that we'd be certain that there are no bugs in the interface, but also that we could compute enough statistics to be assured that the quality of the data was pretty good. So basically, after this pilot, we had all the figures that we were planning to use to justify the data set in kind of a paper context, computed and looking reasonable. Okay. And this was essentially the end of our development process. At this point, we were pretty confident. And so we went on to a full kind of collection process. There wasn't actually much to do at this point because we'd spent so long on development. And so all we did was really scale up the pilot and click play with the one caveat that we were expecting the pool of workers to increase rapidly. And this did happen. And so we added a qualification task where essentially every worker would have one trial conversation with somebody who is already qualified. And then we would manually inspect that conversation And if it was long enough and not repetitive and annoying in some way, we qualified the trigger. So that's it. Just to conclude the kind of overall process for QUAC, the kind of unique elements here are essentially how little time we spent actually getting conversations on a crowdsourcing platform, but instead looking at conversations that we were personally collecting and making kind of fairly big decisions about the form of the collection process based on a few high quality simulations. Once those were completed, there's actually fairly little to do in terms of scaling out to Amazon Mechanical Turk, because we're intimately kind of familiar with how the task would play out. And so at that point, the kind of collection process was fairly straightforward.